Okay, now that you have a better sense of the science of what's actually going on, it's time to start writing down in more detail what the actual events on camera are going to be. And for me, I find the easiest way to start doing that is to literally write them down in the form of a storyboard outline. In this case, I have a number of different chapters that I've described, and these go beyond what we've been talking about in the context of this particular project. We're really looking at chapters 1 and 2 in this particular class project. But it applies to every one of the chapters in the sense that I'll start to describe in more detail what's happening to the camera. And I'll usually be doing this while I'm also very roughly sketching out what the scenes might look like. And my storyboarding abilities are just not at a level where I feel like I get a lot of precision in terms of how the camera moves are going to happen. But at least this type of sketching starts to give me an idea of the relative scale of the different elements in the shot, and that has a direct impact on the type of model that I need to create, the amount of detail involved, how much background do I need to do. And it just provides me with a visual outline of what's going to happen. So very quickly, I was thinking in this particular sketch, you'll see it's a little bit different than what the final movie turned out to be, but in this kind of exploratory progression, I thought it would be nice to start at the level of the intestine itself, go down to the level of the villi, and villi have individual capillaries that where red blood cells are flowing through them, to go in on a close-up of a villus, and where now we can start to barely make out particles, and now zoom into the surface where we have microvilli in the background and the viral particle. And I thought that even before we start the story of how the virus changes shape, that it would be nice to review some of the basic structural features of the virus. So to do a cross-section here, kind of a stop in time where all of the action freezes and we take a second to review the structural aspects of the virus, the symmetry. And then we go back to the action, and chymotrypsin, your digestive enzyme, rushes in, and we can make it look as if it's attacking the virus. Of course, in real life, proteins don't really know where they're going. These are all going around with random Brownian motion. So, but that's a topic for another day. So in this case, we can animate the enzyme going towards the virus, and then in a future storyboard that I don't have here, the outer shell of the virus gets degraded, and the infection proceeds. So in the next movie, now we're going to start to dig into really what we need to do to get the data, to create the beginnings of a prototype in terms of our models, and to get a bit more hands-on with the production of this molecular animation.